Okay, hello my students. Your physics teacher Hassan Darwish with you. This is in reality, this is chapter 1 of a general science class book. And I'm going to explain this chapter through a series of videos. So let's start. In this objective, I want to understand the scientific concept of work, power, and energy. Clear? And in this video, I'm going only to explain this objective. Right? But I want to remind you with the physical concept of work, or review with you the concept of work from from the last year. So let's start. You know, from the last year, the word work as used in everyday language has more than one implication and gives an impression of an effort, right? But this meaning of work is different from the scientific concept of work as used in physics. So what does the term work mean in physics? So work. In physics, we say that a force, we must have what? Force. A force applied on a system, which could be a body or system of or group of bodies. Perform work when it participates in its motion. Means what? Means when you apply a force on a body and the body is in motion, then this force does work. Clear? So there is no work without a force and a motion. Means no force, no work in physics. No motion, no work. For example, you try to push the wall of your room. You know that the wall is not displaced. So there is a force, but there is no motion. So there is no work. Keep it in mind. Okay? No force, no motion, no force, no work, and no motion, no work. To have in physics work, you must have force and displacement, means force and motion. Okay? So the first point, work done by a constant force in a rectilinear displacement. Here we have a body on a table, say, on any horizontal surface. Now what did we do here? We have applied a force on this body at point A. The body is displaced from A to B, clear? Through a distance D. And this is in reality a rectilinear displacement. But the force is constant here. Why? Because the length of the force remain constant and the direction also remain constant, since this angle theta is constant. The vector remain parallel to itself during motion. So this force is constant and the displacement is rectilinear. What is the legal rule for this work? Now by definition, the work done by F is the dot product or scalar product between the force F, which is a vector, and the displacement AB, which is another vector. So F dot AB. And you know that in mathematics, dot product means what? Norm of the first vector means F. Okay? Times the norm of the second vector or the length of the second vector AB times the cosine of the angle, here is time, between the two vectors, here it is angle theta. So F means the magnitude, the norm. D is the norm or the length of the vector AB from A to B, and the angle theta. Clear? In SI units, the force is in Newton, as you know, distance in meter, now work is in joules. Okay, any problem? So you see now, this work, which is W, is an algebraic quantity. Means could be positive number or negative number. You know the meaning of algebraic quantity. This quantity is a positive number or a negative number. So the sign depends what? On the angle theta. If theta is acute, I mean between, here is theta. Let me change here the color. Here angle theta. If the angle theta is between 0 and 90, like this case, then the work is positive. We say in this case the force in reality helps the box in its motion. We say that the work is motive. But if theta is 90 degree, pi over 2 or 90 degree, then cosine theta is 0, right? Then the work done by the force is 0. This is a case of the normal. You know that the normal force is perpendicular to the displacement, to the surface, right? So normal perpendicular to the surface means perpendicular to the vector AB. So the angle between the two vectors is 90 degrees. So the work is 0. Now if theta is obtuse, I mean between 90 and 180, then cosine theta is negative. So the work is negative. The force in this case resists the motion of the box, and it is said to be resistive. As an example, who can give me an example about resistive work? In this case, what? Friction force, right? Friction force opposite to motion, right? Means opposite to displacement, AB. Or you can say opposite to the velocity vector. So the work done by the friction force in case of sliding or translation is negative. Okay? That's the main concept of the work done by a constant force. Now, let's solve this direct application. Here in the adjacent figure, we have a car pulled up by a worker who exerts on it a force of 1400 Newton. This force F is 1400 Newton. The total weight of the cart is 1200 Newton. So the weight is 1200 Newton. Neglect what? Friction. Calculate the work done by each force acting on the cart for a displacement of 1.8 meter and tell whether each work is motive or resistive. Okay? So let's solve this exercise. We want to find the work done by each force for displacement 1.8 meter. We have forces and we have displacement or motion. So we must have work. First of all, we have to find or to determine the forces acting on the system. This is a simplified picture. Here is the slope A to B. put this point, say A. Here is point, say A. And here is point B. And the car has displaced from A to B, which is a distance of 1.8 meter. Okay? So this force of the worker makes an angle 10 degrees with a slope AB. This is the normal and this is the weight. There are three forces. Force of the worker, the weight, and the normal. Let's find the work done by each force. Work done by the weight. mg, which this is F in reality in the language, not force of the worker. This is F. F dot AB means norm of F times norm of AB times cosine theta. Now what is the norm of the weight? Here the weight is given directly, not the mass. For weight, the total weight is 1200 Newton. And the distance AB from A to B is 1.8 meter. Okay? Here it is. Okay? Now, equal. The weight magnitude, put it here. Magnitude of the weight is 1200 Newton times magnitude of the vector AB, which is the distance from A to B, 1.8 meter, times cosine. Now we need the angle between the displacement vector AB and the weight. I think it is very easy to verify that this angle here, this angle is 110 degree. Okay, cosine 110. So you do the calculation, it is minus 739 joule. Now it is negative, means this is resistive work. Okay, it is resistive. Any problem about this force? Direct application only. So let's find the work done by the second force, which is the normal. N dot AB, notice here, normal perpendicular to the vector AB. So cosine 90, 0. So the work done by the normal is always 0. We are left with F only. The work done by F is F dot AB. The norm of F, norm of AB, cosine theta. Now what is the angle between AB and F? Look here at the given. This is the vector AB, or this is the slope AB, and this is F. The angle is 10 degree. You see? So F is given 1400, right? F is given 1400 times 1.8 times cosine 10 degree. The answer is 2482 joules, and this is positive. So it is motive work. So the work done by F is motive. Okay? Any problem? Okay, that's enough in this video. See you in the next video when I explain the work done by the weight and the work done by the force in rotation and other physical points. Take care. Bye bye.